Okay, so let's discuss those priority queues data structure that we are using in more details. I assume you have seen the basic data structure in CS 225. So it's a data structure that supports creating a queue, find the minimum value stored in the queue, extract the minimum, insert and delete a value from the queue. And then, as I mentioned, Fibonacci heaps supports decreasing the key. And then some of them support interesting operation like merging two queues and so on, which is kind of useful in implementing the other operation. The naive implementation of decrease key by doing insert and delete. Sorry, the other way around. You delete and then you insert. But some of those data structure, you can also do it somehow directly. So here is how the Dijkstra algorithm looks with using those queue more directly, right? We maintain in the queue pairs, which is the vertices and the current candidate values. And then now we do this decrease key. Of course, in the decrease key, if the value we are trying to decrease is not improving over the current value, we don't bother to do the decrease key. So it's being called only if the new value is indeed smaller. And overall, there are n insertions, n extract min operation, and m decrease key operations. So this is log n, this is log n, and this is O of 1, as we said. So overall, we get the n log n plus m running time. Right, so as we said already, the easy implementation of a heap, you're just using a balanced binary search tree. Pick your favorite one, is n plus m times log n. Using the smarter data structure, you get, since the decrease key take constant time, then we get running time, as I mentioned, of n log n plus m. One nice thing about the Dijkstra algorithm is to realize how fast it is if you implement it using Fibonacci heap. Because if the number of heap is larger than n log n, then the running time is O of m, which means that it's linear running time, which is kind of pretty surprising that you can do that. The Fibonacci heap is kind of a headache to implement. It's not trivial, and analyzing it is a pain. That's why you have not seen it. You probably have not seen the analysis before, the data structure before. There are other data structures that achieve the same thing, and people implement the Fibonacci heap. It's not that difficult to implement. So for example, the Boost library, which is a C++ library that implements all the algorithm we are seeing in this class, implements Fibonacci heap. Okay, and this is it.